Hey guys, so for questions 17 and 18, we've got triangles. We've got specifically triangles. We've got the third side rule first, and then we're looking at similar triangles. So page 167, the third side rule. Let's look at question number 17. If 7 and 10 are the lengths of two sides of a triangle, which of the following could be the third side? Now, the third side rule is one of only two rules that you apply when you don't have a right triangle. If you don't have a right triangle, you can't do things like the Pythagorean theorem. But you can do two things. You can do all angles together, sum of the angles is 180, right? So the three angles together sum to 180. And you've got the third side rule, which is this. The third side has to be greater than the difference between the other two. And it's got to be less than the sum of the other two. The third side has to be greater than the difference between the other two, and it's less than the sum of the other two. So we very quickly see we have sides of 7 and 10. So which of these following can be the third side? Go ahead and try it for yourself. Just take a second and figure that out. Pause it if you need to. Okay, let's do it. So we know that the two sides are 7 and 10. So the difference is 10 minus 7. That equals 3. So the third side has to be greater than 3. And then the sum is going to be 10 plus 7, which is 17. So the third side has to be greater than 3, smaller than 17. So A is out because obviously that's not greater than 3. And then 17's out because it can't be equal. It can't be equal or else the triangle would never go. You can imagine a triangle like this, right? That third side is bigger. That third side is bigger. If that third side was the same length as the other two, it would go something like this and not connect. So 17 is not going to work. It can't be exactly the same. So the answer is going to be B, C, and D. Anything bigger than 3, less than 17 is going to work. So B, C, D. Question 18 is going to be a little bit more involved. We're on page 170. Let's talk about what similar triangles are. Similar triangles are triangles that have all the same angles. So every 30, 60, 90 triangle is similar to every other 30, 60, 90 triangle. You know, whatever it is, as long as the angles have the same measurement. We do here, we have x, x, y, y, z, z. So what do you get if you have similar triangles? Well, this is what you get. You get, whenever you get the relationship of one side to another, let's say this side is 6 and this is 2. Now, it's from y to z, it's from y to z, so that's what we call corresponding sides. So once we get that relationship of those sides, then we know that that relationship is going to continue. So the relationship is 3 to 1. The bigger triangle is 3 compared to 1 for the smaller triangle. Now this relationship applies to all the sides and also to the height. So if we look at this, we can see that, you know, if this was going to be, for example, this side was going to be 3, this would be 9. If we draw a height in here like this, if this height is going to be 7, this height is going to be 7 divided by 3. Because you're going to maintain that 3 to 1 ratio of large to small. Okay? That's what you get if you have a similar triangle. The sides and the height all maintain that same ratio. How do we recognize them? Well, typically on the GRE, they're not going to give them to you side by side. What they're going to do is they're going to give you more like a nesting triangle like this. So you can see we have this triangle BDE and we have this triangle BAC, and they're sort of, you know, concurrent. They have a shared angle. That's the first thing you're looking for when recognizing similar triangles, is a shared angle. So that's going to be angle B. The next thing you're looking for is the word parallel or right angles. Well, here's a parallel right there. We've got a parallel, see that? Parallel right there, this line, this line. So we have parallel lines. You know what happens when you have parallel lines is that they intersect with a straight line at the same angle. The parallel lines are going to intersect at the same angle. So this angle is going to be the same as this one, and this angle is going to be the same as this one. So when you have parallel lines, you always have similar triangles because you're going to intersect at the same angles. And then don't forget that you might have a right angle. So here's how a right angle would work. If we had two triangles here, this is the shared angle, and then look, that's 90, that's 90. Well, if two angles are the same, and they always total 180, then three angles are the same, right? If two are the same, then three are the same. So this angle will be the same, this is 90, and then you've got the shared angle there. So this would prove to us that we have similar triangles. That means question number 18, page 171, these are definitely similar triangles. Because we have the parallel, because we have the shared angle. So triangle BDE right here is similar to triangle BAC, which is the bigger one right here. And it's your job to figure out the area of that smaller triangle. So take a couple moments, look at that, pause as you need to, and then we'll get right to it. Okay, so what we're told here is that side AC is 10 and that side DE is 5. So that establishes a relationship of 2 to 1, right? So the large triangle to the small triangle is going to be 2 to 1. That's going to be the measurement of all the sides and also the height. Well, that's really important because they give you the area of the bigger triangle. So what you want to get right there is, look, you get that height. You've got a right angle here, you've got a right angle here. This is the height, so we'll put a big H, and this is the height, we'll put a little h. So we know the area of the big triangle is 40. So 40 equals base times height divided by 2. That's what area is, base times height over 2. So 80 is equal to base times height. Well, we're told that base is 10. So 80 is equal to 10 times h. 80 over 10 equals h. So the big height is 8. The measure of the big height is 8. That means the smaller height is 4. Therefore, the area of triangle BDE is 4 times 5 divided by 2, and that's going to be 10. Now, a lot of people are tempted to say 20 here, because once they establish that relationship of 2 to 1, they want to come over here and go, okay, 40 divided by 2 is 20. But you can't do that, and here's why. An area is in 2 dimensions, not just 1. This relationship applies to single dimensions, such as the line that is the height or the line that is the base. If you think about the area of the formula for the area, it's base times height divided by 2. So if the base is half the size and the height is half the size, then the area is 1/4 the size. Aha! So what we could have done instead of all of this, we could have said if the relationship of the height and the base and so forth is 2 to 1, then the area is in 2 dimensions. So what is 2 to 1 squared? 2 squared is 4, 1 squared is 1. So this would be 40 divided by 4, because the relationship is going to be 1/2 times 1/2, which is 1/4. In 2 dimensions, you square that ratio. In 3 dimensions, well, that's when you cube it. So that would be interesting. If you cut the sides of a cube in half, you cut the volume to 1/8. 1/2 times 1/2 times 1/2, 1/8. So correct answer for this one is going to be answer choice B, 10. Okay, now we do something called interquartile ranges. So click on the next video if you want to check that out.